So you must be wondering, how can we have a cool HCF and LCM theorem? By the way, what's a theorem? A theorem is, for now, just mathematical truths that you can prove. So what's a really cool fact about HCFs and LCMs that I can prove for you today? And here's an interesting fact, so that should get your thinking juices started. So let's look at the LCM. So let's look at the LCM of maybe 4 and 6. Here's the LCM of 4 and 6. Well, you know the LCM of 4 and 6 is 12, and you know the HCF of 4 and 6 is 2. And here's a really neat fact. 4 times 6 is equal to 12 times 2, right? Okay, that must be an accident, so let's try another one. LCM of 9 and 12. So the LCM of 9 and 12 is 36, and the HCF of 9 and 12 is 3. So now, let's see. 9 12s are 108, and lo and behold, 36 3s are also 108. Phew, that's kind of weird. Is that a general fact? Is that generically true? That's the real question that we are thinking about. If you have two numbers, and let's say the LCM of A and B is equal to H, and the HCF of A and B is equal to K, is it true? That's what you're thinking, that if you multiply A by B, you get H times K. And this is the question that we're going to try to answer. So just before you go on and play this video, I would like you to really think about this question for a while and try to answer this question in general. It's kind of fun to think about these problems, and even if you can't solve it, you'll still gain a lot of benefit by just pausing the video and thinking about this problem. Okay, so now hopefully you have paused the video, you have thought about it, you may have solved this problem, you may not have solved it, it doesn't matter, you at least tried. That's an important thing. So now let's think about it in general. Why is this true in general? So if you think about a problem like, so let's pick out two numbers. So we have numbers A and B. So let's look at a number A, and A could be some random number. I'm just putting out some random number. 2 raised to the power 7 into 3 raised to the power 0 into 5 raised to the power 3 into 7 raised to the power 2. And B is another number, which is like 2 raised to the power 4 times 3 raised to the power 2 times 5 raised to the power 2 times 7 raised to the power 4. So there's two random numbers, and I want to find out the HCF and the LCM. Now note, in the HCF, what we do is we are picking out the highest common factors, so we always pick out the least one, right? So for example, in the HCF, if I look at the HCF part is going to be blue. So it's going to be 2 raised to the power 4, because 4 is smaller than 7 if I look at 2's. Then it's going to be 3 raised to the power 0, because 0 is less than 2. It's going to be 5 raised to the power 2, and then it's going to be 7 raised to the power 2. So HCF will really be equal to 2 raised to the power 4 into 3 raised to the power 0, which is really 1, into 5 raised to the power 2 into 7 raised to the power 2. That's the HCF. Now, what about the LCM? So let's think about the LCM. If you look at the LCM of these two numbers, remember I'm picking out the highest powers. So if I pick out the highest powers, then clearly I'm going to get 2 raised to the power 7, 3 raised to the power 2, 5 raised to the power 3, and 7 raised to the power 4. So the LCM is going to be 2 raised to the power 7 times 3 raised to the power 2 times 5 raised to the power 3 times 7 raised to the power 4. But now you can clearly see that if I multiply the HCF with the LCM, I'm going to get exactly something that's going to be equal to A times B, because I have taken care of all the prime factors of A and all the prime factors of B, and I'm just multiplying them. I've just changed the order because in the HCF, the blue prime factors of A and B showed up, and in the LCM, the red prime factors of A and B showed up. So when I multiply them, and since all the prime factors of A and B are either blue or red, so when I multiply them, I get the entire thing. So this is really a beautiful fact that the HCF times LCM is equal to A times B, and the proof is fairly simple but really nice and pleasant. So hopefully you enjoyed this proof, and I would suggest that you do some practice problems. Really try to understand how this theorem worked, explain it to a friend, and have fun thinking about it. Thank you.